السلام عليكم. السلام عليكم طلاب.
وعليكم السلام دكتورة.
Okay, تمام. So last thing we spoke about those shifts, bathochromic and hypsochromic shifts, red and blue shifts. Today we will speak about solvent and solvent effects. So first thing is solvent pH effect. We have example is phenol. Phenol considered as weak acid. So increase the pH of solvent on phenol. What does mean increase the pH? It means the pH level should above 7 by adding some base, for example. So phenol is considered as an acid. When base is added, it will convert it to phenoxide ion, as shown in this equation. So this means shifting the reaction to the right side. Add more non-bonding electrons to the molecule will form on inoxide. So higher extinction coefficient, we call it epsilon, and greater delocalization. This means bathochromic shift or red shift or higher wavelength. So we can see here the absorbance will shift from 270 to the phenol to higher wavelength 287, and the coefficient will be increased as well from 1450 to 2600 to phenoxide ion. This means it will form bathochromic shift due to increase the pH. On another hand, when we take aniline, it is base. So when we decrease the pH, because it is already base, we will decrease the pH. Aniline is considered as base, so decreased pH shifts the equilibrium to the left side of this equation. This leads to lower coefficient, epsilon, and lower wavelength, less decolization. So you can see here the absorbance was 280, then it became 254. And the epsilon coefficient 1430, it decreased to 169. So huge decreasing due to decrease the pH of the solvent. So we discussed this before, hypsochromic and hypochromic effect as well. So hyperchromic means increase in the absorbance density, not shift, but increase in the density of the peak of the absorbance. While Hypochromic means decrease in the intensity of the peak. Okay, let's see what is the chromophore mean. Chromophore consists of two parts. Chrome in Greek means color. So chromophore is the group or part of the molecule when the absorption proceeds and causes the color to the molecule. So it is the part which is responsible about the color in the substances, such as azo group, nitro group. So those groups give a color to the compounds which they containing. Mostly unsaturated groups are responsible about imparting. So there is a typo here. It is not imparting, it is imparting. I changed the word. Just give attention to this word, please. Imparting the color such as carbonyl in aldehyde or ketone, or ethylene group, CC group. And there are two types of the chromophores, independent and dependent. So what is the independent chromophore? Independent chromophore, if one chromophore is required to impart the color, for example, azo group or nitro group. So it is enough to give the molecule a color. While dependent chromophore, if more than one chromophore is required to impart the color. يعني نحتاج أكثر من chromophore موجود بالجزيئة حتى ينطينا الكلر. مثلا جزيئة البنزين هي already بيها saturated، بيها conjugated، يعني بيها chromophore، لكن هذه الكروموفور not enough to give the molecule a color. لكن من نضيف لجزيئة البنزين أو السايكلوهكسين مثلا كروموفور آخر مثل النيترو، الآزو، الكربونيل، نشوفها تنطيها لون. مثال آخر الأسيتون. For example, acetone is colorless. When we add diacetyl, it will change to color or yellow color. So, for example, we have some groups here. You have to save them in your memory. So simple chromophoric groups. CC can absorb at this maximum absorbance. C double bond C at 1900. Carbonyl in aldehyde or in ketone. It has 2 maximum absorbance. Hydroxyl 1850. Nitro 2800. And phenyl 2 absorbance. This means we can see 2 peaks, 2 phenyl and 2 carbonyl group in the UV visible. So we have a new term here, Oxochrome. So what is the Oxochrome? Oxo is a Greek word as well, means increase. And we can consider it as a dependent chromophore. So it depends on another chromophore in the molecules. For example, we have hydroxyl, amine, OR group in acetyl group, in acetyl compounds, in ester compounds, for example. So when these groups present in some molecules, they didn't they don't give any color if they found alone without another chromophore. So they are dependent chromophore. And when they exist with another chromophore, they will lead to intensifier or deepening the color of the molecule or the chromogene. For example, if the amino group attached to the benzene, which is colorless, the absorbance will change from 255 to 280. So it will increase the absorbance of the benzene or intensify the absorbance of benzene molecule. We spoke about these terms as well before, bathochromic group, or we spoke about, bathochromic and hypsochromic shifts. Here we have bathochromic and hypsochromic groups, which they are responsible about those shifts. So bathochromic groups, they are responsible about bathochromic shift, and hypsochromic group responsible about hypsochromic shift. So when we have bathochromic group in a molecule, this will lead to red shift, means higher wavelength. And when we have hypsochromic group, this will lead to decrease the absorbance of the molecule. So bathochromic groups will shift the wavelength or the absorbance from yellow to blue-green to higher wavelength, while the hypsochromic will displacement to shorter wavelength. For example, hydroxylamine and esters group. So we have a Woodward-Fieser rule. So this scientist studied or put a certain rule for correlating lambda max or maximum absorption with the molecular structure of diene. يعني درس العلاقة بالداينات التراين بولين، يعني هالمركبات اللي بيها conjugated بها double bond. شنو درس بيها؟ درس العلاقة بين التركيب والامتصاصية، شلون جاي تزداد، وأخذ مجموعة مختلفة من هذه المركبات اللي هي مثلا إحادية أو ثنائية الحلقة، بيها substituted داخلي، بيها substituted خارج الحلقة. نشوف شنو وجد he found homonuclear diene as this one when the conjugated of double bond happens in the same ring. So homonuclear means same ring. Conjugated happens in the same ring as shown in this figure. And he studied heteronuclear when the conjugated happens, both of them homonuclear. So hetero, as in this figure, in two rings, in two different rings. So the conjugated happens in two different rings. And he put two terms, endocyclic and exocyclic. Endocyclic as well means in Greek within or internal, within or internal effect. So endo means within. This within the molecule. Sorry, I think this, yes, within the molecule endocyclic. And if it is in another molecule, it will call exocyclic double bond. Means one of the double bond outside the ring. Yeah, I think this one. Yeah. So this, sorry, this exocyclic, because it is outside the molecule. And he put some values here for parent value, for example, acyclic heteronuclear conjugated diene. He found this value 215, and for homonuclear conjugated diene 253 nanometer. For acyclic triene 245 nanometer. So when we add alkyl substituted to those compounds, we will find 5 nanometer increasement. So we have to add 5 to those values, the parent value of the molecule. And for example, if we have double bond extending conjugation, it will increase 30 nanometer to the wavelength. Thiol will increase 30 nanometer as well. So you have to save these values in your memory. This depends on you. We have example 1,4-dimethyl cyclohexane 1,3-diene. So we have a practical example here. So this is the molecule. It has internal conjugation here. So the parent has 253 nanometer absorbance. When we add 2 alkyl group here, the absorbance will increase 10, because each one will increase 5 value to the molecule. So we have 10. When we add 2 rings residue, we add 2 rings, 1 ring here and 1 ring here, sorry, we will get 10 nanometer increasement as well. So the total increasement will be 20, and when we will add it to 253, we will get 273. So this is the Woodward-Fisher rule calculation. So we will discuss solvent effect on the intensity of peak. I mean UV visible absorbance peak. We have hyperchromic and hypsochromic effect, as we mentioned before. So hypochromic effect means increasing in the absorbance intensity, while hypochromic means decrease in absorption intensity. We discussed this before. Just refresh your memory. If you remember. And this another figure. So here the hypochromic and hyperchromic. Okay, so we have 2-methyl-pyridine as shown in this structure. We will see the solvent effect on this molecule especially. So when we have hexane, lambda max 260. When we have chloroform, it is a chlorinated solvent, the absorbance will increase slightly. And when we have ethanol, the lambda max will still as it is. When we have water, polar solvent, the absorbance 260. But where is the difference here? The difference in the coefficient efficient and the epsilon value. So we have 2000 here with hexane, 4500 with chloroform, with ethanol 4000, with water 4000, and with mixed ethanol with the acid. This means change the pH of the solvent. It will increase obviously. So we discussed before the transitions which can happen in the molecules. And we said there are 4 types of transitions can happen. Actually, there are 5. We missed one last time. And we discussed the major transitions can happen. We have here pi to pi star transition. So this transition is stabilized with polar solvent association with a hydrogen bond or H bond. So when we change the solvent from non-polar to polar, we will get redshift, bathochromic shift, means to higher wavelength. So polar solvent will affect this transition and draw the absorbance to higher wavelength. Means it's increase in lambda maximum and decrease the change in energy change, delta G. While in N to para star or bi star, sorry, transition, N state is much more easily stabilized. So the case here in opposite to bi star transition. So we will get hypsochromic shift and decrease in lambda max value, increase in delta G value. This figure explains the previous explanation. So I nearly finished the instrumentation and solvent effect, values about or terms about UV visible technique. Let's see what is the or what are the applications in organic compound. So UV-Viss helps to show the relationship between different groups. It's useful to detect the conjugation of compounds. يعني احنا لما نقيس طيف المركب ونشوف البيكات وين راح تطلع. بالخبرة by experience احنا ممكن نتنبأ بالستراكشر مالت المركب، نتنبأ انه بي مثلا conjugation، نتنبأ ب functional group. Okay, detection of geometrical isomers. In case of geometrical isomers, compounds that trans isomer, cis isomers. شوف رغم انهم كلش متقاربات السيس والترانس، لكن اليو في visible ممكن ينطينا indicator انه هذا سيس وهذا ترانس من مكان او region مالت البيكس. Detection of functional group. It is possible to detect the presence of certain functional groups with the help of UV-Viss spectroscopy. And general application for UV visible spectroscopy, quantitative analysis, UV-Viss absorption can characterize those type of compounds which absorb UV radiation. Identification is done by comparing the absorption spectrum with the spectra of non-compounds. As you discussed this in the first experiments in your lab. So you determine the you determine the aspirin quantity in unknown regarding to calibration curve you already done by certain quantities of samples or known samples. And it's as well useful in a quantitative analysis of compound. Detection of impurities. UV absorption spectroscopy is the one of the best method for detecting impurities in organic compounds. How we can detect the impurities? It is easily to notice there is messy in the UV visible spectrum. If you notice there is messy, this means there is impurities in the sample. If you can't see clear peaks in the spectrum, this means there is impurities in the sample. So, teutomeric equilibrium. UV spectroscopy can be used to determine the percentage of various keto and enol form present in teutomeric equilibrium. As well, we can use it in or follow the kinetics of the reaction. And I think you studied this before in stage or second stage. You studied the kinetics or rates of the reaction. So UV spectroscopy can be used to study the kinetics of reaction. Molecular weight determination. Molecular weight of compounds can be measured by spectroscopy as well. Analysis of inorganic compounds. As you discussed this in your experiment, so you add inorganic reagent, FeCl3, to the unknown to change it to the color media and determine the quantity of the aspirin by forming a complex. Measuring concentration of solution, absorption band, can also use to determine the concentration of compounds in a solution. So Lambert-Peer law is a good explanation for this point. So we can calculate the concentration using Lambert pair. Absorption equal to concentration multiply length of the cell multiply the epsilons or coefficient. In organic chemistry, absorption spectra have been used in connection with many problems in organic chemistry. So this point means using the complexation. Most of the complexation can form color compounds or color solution. So we can measure the solution absorbance using UV visible. It's useful to determine the structure of the chloral. I don't know what this means, chloral. I think chiral, not coral. So from the peak region, peak intensity, we can detect the functional group or conjugation can happen in the molecule. A qualitative analysis. So pharmacopoeial identification of a drug, and it's also include using absorbance and wavelength by taking absorption ratio, here is repetition, as I mentioned before, using Beer-Lambert's law and using absorptivity value by using reference standard. So the question here, if we have a compound without chromophore, how we can know or indicate with its structure? In this case, we have to choose HPLC technique. So HPLC technique, this another in another side for detecting the compounds without chromophore. I have to delete this because it is related to HPLC. So finally, it's similar. It's similar. Study the kinetics, study the complexation. I told you before, it is just repetition. So here, I finished the UV visible technique. And I have more information for you. Solvent and solvent effect. So how we can choose the solvent to measure the UV-Viss spectrum? The absorption band in ultraviolet spectra are very broad as we compare it with nuclear magnetic resonance and infrared spectrum. Ultraviolet spectra of compounds are usually determined in a very diluted solution, and we discussed this before. If we use concentrated solution or solid sample, this will lead to scattering the light, and as a result, we can't see a spectrum to the compound or the molecule. Solvent must be transparent within the value range being examined. Solvent which we choose must be transparent, شفاف, doesn't have any interference with the molecule. Another criteria for choosing the solvent, it shouldn't itself absorb radiation in the region under investigation. It should be less polar to minimize interaction with solute molecule. Spectroscopic analytical grade. So we have mostly three types of solvents. We have synthesis solvent, we have analytical grade, and we have HPLC grade. المذيبات اللي عادة نستخدمها للسينثيسيس تكون يعني مو بذيك النقاوة, not 100% pure. المذيبات اللي نستخدمها للسبكتروسكوبيك تكون analytical grade, يعني مستوى عالي من النقاوة. المذيبات اللي نستخدمها بالHPLC هاي تكون extra pure حتى نحصل على 100% pure of the compound. Solvent for ultraviolet spectroscopy should be analytical grade. The most commonly used solvent is ethanol. Why? Because it is cheap, good dissolving power, doesn't absorb radiation above 210 nanometer. So we have some solvents which are transparent above 210. We said ethanol is good solvent in this region because it doesn't absorb radiation above 210 nanometer. While those solvents, normal hexane, cyclohexane, methanol, water, and ether, they are transparent above 210. So we will get some problem, sorry. Hexane and other hydrocarbons sometimes preferred to polar solvents. Why? Because they are minimize interaction with solute molecule. While benzene, chloroform, carbon tetrachloride, CCl4, chlorinated solvents can't be used. Why we can't use those solvents? Because they absorb in range between 240 and 280. So they are not preferable solvents because they are absorbed. They make interference with the molecule, with the solute. Generally, polar solvents such as water, alcohol, esters, and ketones tend to destroy the fine structure due to vibrational effects. هذول المذيبات يحطمون التركيب الكيميائي أو الجزيئي للسوليوت due to vibrational effects. So some solvents for electronic spectroscopy would give attention to the absorbance region. So water, 205 nanometer. This is the lower wavelength limit. Ethanol, 210 nanometer. Hexane, 210 nanometer. Cyclohexane, 210 nanometer. So if we look at the wavelength which they are absorbed, we can notice they are absorbed in ultraviolet region, not in the visible region. And that's good. So we can use them in the visible area. Chlorinated solvents, chloroform and CCl4, slightly higher, 245, 265, and benzene 280. So we usually avoid benzene in UV visible. And it is toxic, it is flammable. So we have solvent effect here. It's, I think, French term, solvatochromosome. It is the ability of a chemical substance to change color due to change in solvent polarity. So when we change the polarity of the solvent, we will get this term or this shift. The sign of solvatochromosome depends on the difference in the dipole moment of the ground and excited state of the chromophore. I think you know the dipole moment mean. Dipole moment means or dipole moments mean two different ends in the molecule. For example, positive and negative. And this leads to form dielectric constants as well. And dielectric constants of solvent is measure of its polarity. The higher the electric constant of solvents means the more polar it is. For example, water has dielectric constants 80, while methanol 30. This means water more polar than methanol because it has higher dielectric constants than methanol. So the presence of specific and non-specific interaction between the solvent and solute molecule are responsible for what? For the change in molecular geometry, electronic structure, and dipole moment of solute. This solute-solvent interaction affect the solute electronic absorption spectra, of course. So we again back to the chromophore. And we mentioned that the unsaturated group capable of absorption of radiation because it is weak chromophore. Chromophore may have bi-electron or non-bonding electrons, which may undergo bi to bi star and N to bi star transition, as we mentioned this before. Chromophore was applied to the system responsible for imparting color to compounds. For example, ethylenic group, acetylene group, carbonyl in aldehyde or in ketone, acids. Here we mean carboxylic acid because it is organic compounds. So we don't deal with, for example, hydrochloric or nitric. We will deal with organic carboxylic acid, esters, etc. Exochrome. So what is the exochrome? Exochrome, as we mentioned before a few minutes, it is dependent to chromophore. It is deepen the color of the chromogen. يعني هو إذا موجود الوحدة ما ينطي كلر، لكن إذا موجود بالإضافة إلى كروموفورم آخر هو راح يعزز الكلر، يقوي الانتنسيتي for the absorption. And this will lead to bathochromic shifts, red shift, because it increases the wavelength of absorption. And therefore moving closer to infrared. If you remember, let's see this one. If you remember this chart here. So when we will move to right side, we will get infrared. So this is the red shift. And this is the bathochromic shift. Oxochromic are fully saturated group with one pair or electrons of electrons. Sorry, I skipped this. Oxochrome, when attached to the chromophore, see, shifts the absorption peak, should be shifts the absorption peak towards the longer wavelength. We discussed this before. So bathochromic shift, a shift of absorption peak towards longer wavelength, and it's called bathochromic shift or red shift or positive solvato chromosome. And this shift can be seen with increased polarity. يعني لما نزيد قطبية المذيب راح نحصل على البارا ستار باي ستار transition. The increased interaction between the solvent and the absorbing species lower the energy level of excited and unexcited state, but the effect is seen more on the excited state. This figure explains the above note. we have example here. Alkyl substitution of olefin shift the absorption maximum to longer wavelength. The shift increases as in number of alkyl group increase. If you remember Woodward-Fisher rule, when we add alkyl group to the olefin, this will increase the absorption maxima. We discussed this in different example. So redshift is seen for phenol because it will form phenolate ion in solution. Alkaline media for paranitrophenol shows redshift because negatively charged oxygen, which led to delocalize more effectively than the unsaturated unshared pair of electrons. يعني هذا delocalize قوى الالكترون بير اللي كان موجود بالاساس على الجزيئه، فادى الى redshift. See the shift here from 255 to 265 to higher wavelength. And we discussed this before as well, hypsochromic shift, or we called it blue shift, to shorter wavelength, higher energy means. And we discussed before a few minutes about the polarity of the solvent. Polarity of the solvent will affect non-bonding electrons. So best example is aniline, and we said the aniline will shift it to blue. To the shorter wavelength, as you can see here, from 280 to 200 nanometer. So to higher energy, to shorter wavelength. Hyperchromic shift. Means higher intensity of the bond. So when the intensity of compounds is increased, it's known as hyperchromic shift. As this example explains, so the shift from 257 to higher lambda max 260. When we add alkyl group to the molecule. So this is the Woodward-Fisher effect. Hypochromic is opposite to the previous one, when the intensity of lambda max will shift to or decrease, will undergo of decreasing in lambda max. I can skip this one, it is not important. So this is the obvious effect. Effect of solvent also affect the finance of absorption band. يعني كل ما كان المذيب هو suitable راح ينطيني smooth أو clear absorption of bands in the UV spectroscopy. So when I choose the right solvent, I will get the right measurements. So if the dielectric constant of the solvent is higher, see, there will be stronger solute-solvent interaction. We mentioned that the dielectric constant of solvent means the higher, or the measure of its polarity, its ability to separate the molecules. So when it's higher, we will get stronger solute-solvent interaction. So those are the references which I depended on, and I have more two references. I will add them later and send you the extra information which we explained now. So if anyone have any question, I'm happy and ready to answer. You can open your speaker. You can open your speaker and have a chat with me. Now, my dear students, now we finished. Can you hear me, please?
Yes, doctor, we can hear you.
Good, great, fabulous. Now I finished the UV visible technique, and we discussed everything, I think, everything about it. So if you have any question, any messy, any something not clear, and we have tomorrow, I think, if it is not Eid, we have another 1 hour. We can make it as a revision hour, if you like. طلاب وياي. طلابي الأعزاء، شباب.
نعم دكتورة موجودين، نعم إن شاء الله موجودين.
الحمد لله، يعني ماكو أي سؤال، كل شيء واضح. أهم شيء
واضح واضح إن شاء الله، واللي عنده سؤال أكيد يعني يطرحه بالمناقشة.
الحمد لله والشكر. إيميلي عندكم، وتقدرون على الكلاس روم أيضا تودوا لي أي سؤال، أي شيء ما واضح لا تترددون. don't hesitate.
العفو دكتورة، بس أكو نقطة مهمة.
نعم.
المحاضرات الصوتية يا ريت ترفعوا على الكلاس.
والله أنا ما أعرف بهاي التكنيك مالت الدبلجة الدبلاج، فأحتاج واحد يساعدني، لأنه بصراحة يعني ما رحت لي، أنا صايمة وعندي ديهايدريشن، فأحتاج واحد يساعدني. فقلت شنو يعني أنزلها كلها سوا اللي ناقشناه.
مو هي دكتورة كل ساعة لوحدها، يعني كل محاضرة يسجل تسجيل خاص بها يعني.
نعم بس اكو يسووا لها دوبلاج.
وايضا دكتوره بخصوص التقارير يعني المطالب يا ريت تدزوها همين على الكلاس.
اي تقارير؟
الجانب العملي يعني.
نعم. شلون يعني ندزها؟
يعني على الكلاس المطالب شنو اللي تحتاجوها مثلا introduction وكذا مثل منها يعني الاشياء اللي تحتاجوها بالتقرير.
نعم ان شاء الله ان شاء الله. هسه خلينا بمحاضره اليوم باليوفي فيزيبل تكنيك. انا نهيت بعد ما عندي اي شيء اضيفه، يعني هاي اللي اشوفه مهم. اهم شيء تعرفنا على الانسترومنت، تعرفنا على الريجن، تعرفنا على الفاكتورز affecting the technique او الميجرمنت، تعرفنا على السولفنت افكت. هذه اهم اشياء باليوفي. وتعرفنا على الابلكيشن، يعني اهم شيء احنا من ندرس فد شيء يكون ب benefits not useless. فهذه كل الاشياء المهمه انا طرقت لها ان شاء الله، يعني بحيل الله ان شاء الله طرقت لها. اذا انتم عندكم اي شيء اضافه ترسلوا لي على الايميل او على الكلاس روم. اي سؤال don't hesitate. واذا تحبون تكون ساعه بكره هي مناقشه، واذا ما تحبون ننهي. اذا كل شيء واضح عندكم فننهي. ما اجتني اي تعليقات. ان شاء الله كل شيء واضح. ورغم الحضور، يعني مو ذاك الحضور 61 طالب فقط. ممثل للمرحله موجود؟ علي؟ مو
دكتور انا ممثل جروب بس عادي تفضلوا ماكو مشكله.
يا ريت يعني تنقل لي اللي يدور بيناتكم
ان شاء الله
بايميل.
دكتوره ان
اي
شاء
والله
الله.
اي شيء ما واضح.
يا ريت دكتوره تدزي لي على الشات اذا فد ايميل او فد جهه اتصال تواصل وياكم يعني.
ايميلي خليته لكم اخر مره من اخذنا العملي.
هذا العصبوره نفسي تمو.
اي نعم. هسه راح ارجع كتبه لك هنا اذا انت وياي على السكرين.
ان شاء الله موجودين.
هذا ايميلي. لك
تمام
جميع
دكتورة
الطلاب.
بس خليها سكرينه دقيقه. ها هي دكتوره.
هذا ليلى دوت عباس @University of Basra educate edu Iraqi. هسه علي، مو علي؟
نعم دكتوره علي.
علي يا ريت يعني ترسل لي خبر انه شنو تردون ساعه بكره نكمل. انا نهيت اليوفي، يعني معناتها ندخل بالاي ار ان شاء الله.
يعني ان شاء الله محاضره غدا ان شاء الله رجعكم خبر بهذا الخصوص.
ان شاء الله.
شكرا جزيلا دكتوره.
شكرا جزيلا.
الله يحفظكم حياكم الله.
في امان الله.